Hello, everyone. Hopefully you can hear us all loud and clear. So yes, it is that time again. I know we're not in the first week of the month, but we are here anyway. Thank you very much for joining us for BrisJS. We've just given everyone a good 5 minutes just to come in and make sure that we've got everyone joining the stream and do some shout outs on Twitter and the like as well. So yeah, thanks for joining us. And yes, Andrei, yes, you can hear us. That's awesome. Thank you for jumping in there. Yeah, it's great to have you here again. And we've got a couple of awesome talks as well to get all those neurons firing and get you all excited about the web developments and all the JavaScripts that we're loving so much. So let's crack into it with a bit of a preamble. 1 second. Okay, that's the button I wanted. Yeah, so if you are at all interested in being able to ask us some questions, we have Slido for that. So you can go on there, punch in some Q&A, leave some questions. You can vote in a little poll afterwards just to get us some feedback if you're interested in giving us some tips or anything that you found could be improved. We're always here to accept that, and you can always get in touch with me as well. So that's the link in a QR code. I've also linked it in the YouTube chat if you want to jump into that as well. If for some reason jumping backwards and forwards, like if you're on a mobile device, doesn't work well for you, don't worry. You can just leave it in the YouTube chat as well if you like, and I'll make sure it gets ferried over to Slido so that we can ask it in one go at the end of each presentation. So yeah, otherwise you can just log in with 222, try and keep that number really interesting. And yeah, we'll move forward from that. Awesome. So I'd like to begin by acknowledging the traditional owners of the site that we're broadcasting from today, which is the Yugara and Bundjalung people. And I'd like to pay my respects to elders past, present, and emerging. And Meetup is still currently where we were able to broadcast some of the details from. It's usually a little bit late these days, just to try and get everyone's information together and post it back up on there as well. Get you the full details and get an email out from that system. It's still, as you've seen, if we've needed to reschedule a couple of times, it's still important to be able to subscribe to that. That way you can keep up to date, get all the latest updates. And that really helps everyone involved. But yeah, we're still using that at the moment and trying to broadcast at least as many places as we can. Also, of course, since it's a community event and this is even in the online space, absolutely something that we need to think about is the code of conduct. So definitely not a new thing. Please go to brisjs.org and have a look at our code of conduct policy. And we expect that should be simple and straightforward for everyone to abide by. The call for presenters, I do this every time, so you should be sick of hearing me say it. This BrisJS presentations are only around purely on the kindness of strangers coming to say, this is something I can tell the world, and we're absolutely here for it. We're here to promote and give you a platform so that you can get all this interesting information out to everyone, and everyone's here to hear it. So yeah, it's really valuable. Please go in and submit a talk. If for some reason you are just keen on a specific topic and you're just like, okay, I'd love for somebody to cover this, but I just don't have the time or resources to be able to dedicate to researching it and presenting it myself. Maybe somebody's already got it and already ready to go for a talk. Maybe someone just needs inspiration. They're keen on doing community talks. They want to be able to peruse some of the different things that are of interest to people. We actually can let you request a talk. So that comes in the same way. You can also raise GitHub issue. So your talk requests and submissions for talks, they will go through our GitHub issues, which look like this once they're tagged and scheduled. So that's lots of talks volunteered, but if you've got a talk request, it can be tagged there too, and it'll appear on the website under our section about presenting. There's also a couple of other web pages that we'd like to at least have a presence on. You can contact us through their chat mechanisms as well. But usually try to put out a tweet when the upcoming events are there as well. And of course, you're on YouTube. You're able to subscribe to us. Hopefully, you're doing the right thing, following us, keeping us going, and seeing all of our live streams as they're announced. BrisJS.org is still a rallying point. Needs a little work. We need to schedule in some after hours time and maybe some community involvement to give that one a spruce up. And then that one will actually go through and just take you through the links of the latest talks on Meetup and provide you a bit of the information that I talked about there for past talks and presenting information. And also a useful feature that's still very current is the job board. So if you're you've got an interest in trying to refer people to where you work, you just want some new friends to come and work with, and you think it's a great place to be. If you see any job postings you'd like to share with the community here, this would be the place to try and put them. So you can do that again through our GitHub issues. There's another link there as well on the post a job section on this page. But you can absolutely do that, and we'll tag it with jobs and employment tag, and it will appear on this page. So this is a really good idea. Just make sure that you can, post some of those up, and it'd be great as well just to follow up and make sure that you can let us know if it's closed as well. Keep this list current. There it goes. It just took a second to move over. Tonight we've got a couple of great speakers for you. Carryover champion, Ashley Davis, who's been with us several times now. We just can't get rid of him. He's here to follow up the talk by Andrei. He's inspired by him in the last BrisJS about observability. So he's here to tell us how he's looking to implement observability in Node.js, which we're all about in our JS-centric world. Then we're going to hear from Murray, who's here to just talk to us about getting that page speed, that absolute critical thing that we're always testing for constantly. So if you're into getting fast front-end loading times and you've got perhaps a very data-heavy, visualization-heavy kind of page or site, this would be the one for you. So he's here to kind of talk about some of the tips and some of the work that's involved in trying to get that page speed going a bit quicker for everyone so they can get that sweet data. Then we'll be closing off and, bringing up our polls, and that'll be us for the night. So I'd like to take this second just to be able to introduce Ashley Davis to you, as if he needs an introduction. Ashley, you there?
Here I am.
There he is.
Hey, Kevin,
Thanks very much for joining us, mate. Not a problem.
I'm sorry, but I don't think you're ever going to get rid of me.
Look, this is fine. This is okay. We're okay with this. I haven't heard any complaints yet, so I think you're okay to stay. Good. And yeah, the floor is yours. Thank you very much, and take it away.
Cool. Hi, everyone. I'm just going to start my timer. I don't actually know how long this talk is going to go because I haven't actually measured it. I budgeted for about 20 to 30 minutes, but I got the timer there. So if I start to look like I'm going to go over, I might kind of rein it in a bit. So this talk tonight is a follow-up from Andrei's excellent talk a month ago on observability. You can find that talk on BrisJS's YouTube channel. I'm going to show you that in a moment. It's a great intro to intro and overview of observability. I'm not going to be covering like any of that in the kind of the basics, and I'll give you my quick definition of observability for what it's worth. And I don't have any slides in this talk either. So I'm just going to give you my quick take on it, and then we're going to jump in and look at some actual code and how to implement observability in an example Node.js project that I prepared earlier. So you'll be able to grab that for yourself and try it for yourself as well if you want. But first, I just want to kind of give my definition of what observability is. I think the best place to go is that talk by Andrei, but like observability is the ability to understand what's going on in our application. And that helps a lot when we experience problems or unexpected behavior and we need to debug it. But particularly it's for debugging applications that are running in production. I mean, you wouldn't normally use this for, something you have running on your development computer. There's better ways to debug that, obviously. And it's most useful for distributed applications and microservices applications. So it's a lot easier to understand what's going on in a monolith. So maybe you don't need to apply observability for that. And for that reason, I've made my example project tonight be a small microservices application with 2 microservices, because that's really the minimum number of services that you need in a distributed application, I think, to start to make or take a benefit from integrating observability. I wanted to learn more about observability for a few reasons. And the first one is that it's like a pretty hot topic right now, and it seems pretty interesting as well. And it's probably been about a year that I've been wanting to kind of invest more time to learn about it. And then recently, or a few months back now, I inherited an application, a microservices application at my company, and there are some problems with it. And I integrated OpenTelemetry and Honeycomb into it so I could better understand what it was doing. So at the same time, I've also been working on the second edition of my book, Bootstrapping Microservices. And in the first edition, there was a chapter on monitoring distributed and microservices applications. And I really wanted to kind of get some experience with this so I could update that chapter and talk more about observability and to introduce OpenTelemetry as well. So by the way, OpenTelemetry is the kind of standard protocol that your service needs to talk in order to send telemetry data to like a cloud vendor for observability tools. And I'm using Honeycomb, and that's what I'm going to show tonight. And that's what actually Andrei recommended to me. So that's why I've started using that. And it seems pretty good to me, but like I don't really have experience with other tools. So it's a little bit hard to compare. All right, so I'm just going to get myself organized and share my screen with you. Okay, everyone see that okay?
Certainly can.
Cool. So this is the BrisJS YouTube channel. I just wanted to show this first because this is where you can kind of find Andrei's talk. If you look at the February 2023 talk, that's where you'll find Andrei's talk. So I thoroughly recommend going into that if you want to get an understanding of the concepts and how all the pieces fit together. I'm going to be showing you some example code tonight. If you go to my GitHub page, that's github.com Ashley Davis, go to repositories. And it should be pretty close to the top at the moment, but you might have to search for it later. OpenTelemetry Node.js microservices example. So this is a small, very trivial microservices application. I've got a diagram here to kind of explain how this works. It's designed to run in a Kubernetes cluster, but tonight we're just going to run it locally so I can show you, I can start it up and show you the telemetry that it sends to Honeycomb. So we've got an entry point into the cluster through the gateway microservice. So we're going to make a REST API request to the gateway microservice. That REST API request is going to get forwarded to a worker service. The worker service is going to do a database query to pull out some database using MongoDB. And then it's going to return that data to the gateway, and then it's going to return that data to the client. So this could be like a backend for a web page, and you're querying the backend to get some data to display on the web page. I've got no front end for this, so I'm just going to show you what the REST API request looks like in the browser. So I'm just going to clone this. So you could get this for yourself. I'm just going to copy the URL. So I do have a local copy of this, obviously, but I'm cloning a new one here just to show you what it's like to start this from scratch. Now, this relies only on having Docker installed. So you can do a Docker compose up on this, and you'll get the application, you'll get the 2 microservices. You don't even need to have Node.js installed because it's just kind of built into the Docker files. If I do a Docker compose up build, that's going to build a version of this microservice. You can see, if you saw at the start there, it's expecting a Honeycomb API key, but because I haven't provided that yet, the OpenTelemetry export to Honeycomb is disabled. And just so I can show you what this looks like before we do that. So we've got a lot of output here from the database, but hopefully we've got some microservices starting up. Give it a moment to start. I really need to update the packages. I've got a few deprecated packages warnings here. Because this is actually, it's not really a new code example. It's based on an old code example that I've integrated OpenTelemetry and Honeycomb into. Hopefully this won't take too long. So that's the worker service online. The gateway microservice is coming online. So that's online. I'm just going to open a browser window so I can show you what a REST API request to this service looks like. So we're going to localhost 4000, API/data is the endpoint, and that just prints a bunch of data. So it's rendered nicely because I've got a JSON rendering plugin installed in Chrome, that's all. So this isn't kind of a nice front end or anything like that. It's just displaying the raw data that's coming back from the REST API. So we'll have a look at the code. I'll just leave that running. And I'll open Visual Studio Code here so we can see what's going on here. And I'm just showing you the general setup here as well, just before we kind of turn on Honeycomb. Zoom in so everyone can see it. So this is a project with a Docker Compose file, and this is what basically sets up the services. And I'll show you how Honeycomb is integrated into that in a moment. We've got a gateway subdirectory, so that's where the Node.js project for the gateway lives. And we've got a worker subdirectory. And so there's another Node.js project under there that is just like a trivial example of a generic kind of worker microservice that might be inside your cluster, but not accessible from the outside. Now, again, this example is just 2 microservices, but you have to kind of try to imagine while I'm doing this that, you know, in production, this might be like 5 microservices or 10 microservices or 20. Like it could be a real application here that we're trying to understand and debug. But this is just a trivial example. Now, if we look in the index.js file, we can see the setup for the Express framework web server here. This is the thing that we're interested in. So this is what we're hitting when we saw that endpoint and we're looking at the data in the browser. We're hitting the API/data endpoint. And it's just using Axios here to forward the request to the worker, which is what that the service name is set to. So you can see there, it's the worker. So it's just forwarding that request to basically the same endpoint in the worker. It's getting back a response and it's returning that response to the client. Nothing too exciting there. And we'll have a look at what's happening in the worker. So just opening up the index.js file for the worker here. So it has basically the same endpoint, API/data. But this time around, it's actually doing a query of the MongoDB database. So it's not very feature-proof code here. It's just there's no pagination. It's just doing a find to get all the documents back, and then it's returning all the documents back. So that'd be returned back to the gateway, and then that'd be returned back to the front end, and therefore we see the data displayed here when I do the query for or when I hit the REST API in the back end. So I'll just show you the diagram just to hopefully make sure all the dots are connected here. So when I hit API/data in the web browser on localhost, what was it, 4000 or something like that, it's basically making the REST API request to the gateway, which in turn is forwarding to the worker, which is querying the database, returning the data to the worker, and then returning the data to the gateway, and then returning the data to the front end. Now, the problem here is like, you know, what happens if something fails in the worker? Like, how do we know what caused that? Well, this is a trivial example. So it's like really easy to know what caused it in this case. Obviously, it's going to come from the gateway and whatever user was using the gateway. So not too hard to debug that, but you imagine there's, you know, like imagine there's 20 microservices in this cluster, in this example, and we don't know who's calling the worker. Like it could be any other microservice, it could be the gateway, and we don't know who's calling that, and we don't know who's calling that. So there's a chain of events happening inside our application, and we don't understand the connections between them. And like once we get to the worker, we probably don't even understand which user is using, you know, is making this request, or any of the other context, or any other details around that. So, you know, with lots of different routes in your REST API and lots of different microservices, it doesn't have to be microservices. It can be larger services. So it's just a distributed app, right? But this is where observability comes to the rescue, because we can integrate open telemetry, and the Honeycomb SDK kind of makes that a little bit easier. So that's what I'm going to be showing you tonight. And then basically, even with just the automated instrumentation that you get for Node.js, like you get so much information, and it ties together the requests that are being changed through the system. And you can see on the diagram I indicated here by the telemetry coming out of the gateway and the worker microservices and being piped into Honeycomb. And so then we could go into the Honeycomb webpage, the Honeycomb dashboard, and have a look at what's happening like in our system. And I'm going to show you, I'm going to give you an example of that in a moment. Okay. So what's the next step? Okay, so I've got to restart this now to enable Honeycomb. So I'm just going to stop my server here. Now I've got to basically set my Honeycomb API key on the command line. And I'll just show you, actually, I'll just show you in the Docker Compose file how that gets wired through. So if we look at the Docker Compose file here, we've got the setup for the worker service here and telling it which Docker file to build for that, etc. All the other configuration environment variables. And here is where we're passing in the Honeycomb API key. So we're taking the Honeycomb API key that is set as an environment variable on my local computer, and we're plugging that in as an environment variable to the worker container, the worker service. So here we've got the setup for the gateway microservice, same sort of deal, the Docker file here, which specifies how to build the Docker container. And then we're setting the environment variable, the Honeycomb API key through the environment variable there. So that's what I've got to set. I've got to take this and I've got to set this on my command line here. Now, if you're using Mac OS or Linux, you'll use the export command. I'm on Windows, so I use set. And the API key, you can actually just get it from Honeycomb. And this is just a test project, so I don't care if people see my my API key here. But if we go into, I guess, my account, I'm just got to remember where to find it. So I've signed up for a free Honeycomb account. Somewhere here, I'm hoping I can find my API key. I'm not sure where it is now. Sure, it's under here somewhere. Team settings, my account. Okay, I don't know where it is. Maybe it's under team homepage. No.
Under environments, apparently.
I do have it. I do have it written down as well to copy over, but I thought we could find it quicker than that.
Yeah,
there we go.
That's the one. Yep.
So I've got an API key here. I'm going to copy that, plug it in there. So now when I restart this, it's going to be connected and outputting this telemetry data to Honeycomb. So once this is started up again, once the gateway is online, I'm going to be able to go into the Honeycomb dashboard and have a look at what's coming out of that. I swear my computer always seems to go slower when I'm doing a live demo. Like this was so much faster when I tested it earlier. Okay, so we've got our gateway online. I'm going to go back to my REST API. I'm just going to hit refresh on that a few times so I get some open telemetry data going through to Honeycomb. And let's have a look at the Honeycomb dashboard. Now, there's a lot of interesting stuff here, and I won't pretend that I know how all this works, but it's pretty cool what you can do with it. It shows you the total number of requests, events that are coming through here. And obviously, it's not very much for this example application. All these graphs would be like full of data, basically, if we were looking at a real production application with proper telemetry integrated into it. On this graph, the latency graph, we can see how slow our requests are, which is really cool. And then we've got an error rate here as well. So this was really instrumental, actually, like in my company's application. Once I integrated it with Honeycomb, I could see persistent errors coming up. And like they weren't all problems. They were just like things actually that were returning HTTP error codes where they shouldn't have been. Like, so they were coming up as kind of like a false positive. But it's just amazing what you can see, on a real application once you instrument it. Now, I want to look at recent traces down here. So this just shows you the data that's sort of coming in most recently. And this looks about right. Was I just babbling on for about a minute after I did that? So I'll just open the first one. And so what you can see here is called a trace, and it's got like a unique identifier here, and it tells you the time. And this is basically it just shows you the chain of requests that have gone through the application. You can see here that it starts with a HTTP GET to the gateway. And then it seems weird that there's another HTTP GET nested under that. I don't know why it's kind of come up with that twice. That would be interesting to look into. But this is what we're really interested in, a HTTP GET to the worker. So this is where we're forwarding the HTTP request to the worker. And it's also picked up our MongoDB find query. So it's picked up the database query as well. Now, each of these colored bars here is called a span. So what we're doing here is we're tracking the execution of various interesting kind of sections of our code, basically, all correlated to the initial event where it kind of comes in. And this just comes from the automatic instrumentation as well. Like I did barely anything to get this level of kind of instrumentation integrated into my application. And I'm going to show you that. Let me show you what the code looks like for integrating that. And I just followed, to get this far, I pretty much just followed the Honeycomb getting started guide. And then, I've done more complicated stuff as well. And I'll kind of give you a hint of, if we've got time, I'll give you a hint of what that is. And I've got some resources anyway. I've got some resources I'll share at the end if you want to kind of learn a bit more about this for yourself. But coming into the code, we'll look at tracing.js in the worker. So we're in the worker microservice. This is tracing.js. So they basically recommend that you add this. And then you basically have to kind of execute this the first thing in your project. And the simplest way to do that is, I think I added to start. Yeah, so you can see here with my start script in package.json that I'm using R to register this script basically before running the main script. So that's automatically running my kind of my OpenTelemetry Honeycomb setup for running my main file. Or you can just literally just import that into your main file. And I think I'll probably do that. I'll do that. No, but I will be doing it in a minute, probably. So I'll show you that in a sec. So this tracing.js file, I'm just going to delete everything here that you don't really need. There's a lot of, I've added a bunch of helper functions, but that's all kind of icing on the cake, really. Like I'll just get rid of that. So this is your starting point. And this is what you get to by going through the Honeycomb getting started guide. You've got some imports of libraries that you've installed, and you're telling the Honeycomb SDK to start up, and you're telling it what automatic instrumentations to use. And here we're telling it to use the automatic Node.js instrumentation. So it knows about Express, it knows about the MongoDB library, it knows about GraphQL. There's probably 50 different things that it knows about that it can automatically instrument for you. And this is why when if we go back to that trace, this is why it kind of knows that we've called MongoDB find. I didn't tell it anywhere in the code that that's what was happening, but the auto instrumentation has injected itself and into the MongoDB library and can capture that information for us. And you can kind of tell on the side here where it comes from, because there's a bunch of fields on the side of every span over here. And you can see where it actually comes from. It comes from a library called OpenTelemetry / instrumentation MongoDB. So if you have, I've seen this with GraphQL as well, it will kind of understand what queries you're making and what's coming back. And it understands how the GraphQL libraries work, which I thought was kind of cool. So this is you get a lot for free. It's pretty amazing. And I did do a bit of the OpenTelemetry bootcamp as well, which I'll give you a link to. But it's so, if you do that, it seems so much more complicated. And of course, we're cheating a bit here. We're cheating because we're using the Honeycomb SDK. So in a sense, we're locking this tracing.js file, we're locking it to Honeycomb. But under the hood, it's just using all OpenTelemetry. And the rest of our code doesn't care. If we need to kind of configure anything or do any kind of events or manual instrumentation, we can just use this one here, the OpenTelemetry API. And so it's only kind of like one file per service that is depending on the Honeycomb SDK. And so you can easily change that if you want to kind of change from Honeycomb to a different software vendor later. Okay. Now we've got a few minutes left before my time is up. So I'm going to show you how to do some more advanced stuff. And I've added a bunch of helper functions just that I can rely on. Now, these are all just using OpenTelemetry under the hood. So I've got a helper function here to make a custom span, and it sort of runs some code. And if an exception occurs, it kind of records the exception. I've got code here to report an error. Oh, sorry, they're pretty similar actually, except this one doesn't make a span. So it's just kind of running some code. And then if there's an error occurs, it's going to report that to open telemetry. We can add attributes. We can record events. I'll show you adding an attribute. So let's do that in the gateway. So one thing you might want to do here is, is VS Code going to pick this up for me? No. I'll set attribute, not add attribute. Looks pretty good. So there's some user. So some user is coming into our backend here from from using a front end somewhere, and we might want to attach their user ID to the span or the current trace. And like normally that might come from the request if you've done some authentication or whatever. Like you might have a user ID or something like attached to the body of the request. Like I don't have anything like that. This example is too simple, but I'll show you what it looks like. You can add like, a user ID 1, 2, 3, 4. I compile that. Hopefully it's updated, and hopefully I can do a couple more requests here and we can kind of see that attribute come through. This should be enough, hopefully. A few seconds ago. Whoop. Just refresh before I saw that. There we go. So hopefully this will have a trace with set attribute. It should be on the outermost call here. You should be seeing a user ID. There you go. So you see at the bottom there, you've got user ID 1, 2, 3, 4. So that's basically allows us to. I've lost it. There we go. So that allows us to understand what user is like throughout this entire trace. Like even if we come down here and we're looking at an error or something that happened in another service, like in the worker service, we can kind of track it back to here and we can say, Bob was using it at that time, something like that. So that's pretty cool. And you can do some interesting correlations. So you can say things like, you've seen that this user has one error. You can do a query to say, get me all all errors that are affecting this particular user. Or you could do it the other way. You could say, get me all users that are being affected by this kind of error that has this error message. So after showing you that, let me show you adding an error message. I'll do this in the worker. So what I'm going to do is I'm just going to simulate an error here. Just throwing an error won't do anything. It won't actually. It'll tell you that there was like an error, like a 500 error or something like that in the request. But just throwing an error like by itself won't hurt. You kind of have to actually just wrap it in something that's going to record the error. And that's why I've got that helper function. Which one do I want to use? Report error. So like what I would do if I didn't have that error, I'd wrap the whole thing. That's to be an async function. So this is a little bit ugly, but I mean, it captures your errors for you and it will kind of send them. So let's say, something in the middle is throwing the error. So I've on purpose, I've put an error in there, but that could be anything, it could be like a bad connection to the database or, something like we're depending on, I don't know, something that doesn't exist. Let me refresh this so I can trigger the error. Oh, yeah. So I'm seeing the error there coming back directly because it's being caught by the express kind of root level kind of handler there and converting it into a 500 error. So we've got that, but the actual details of the error should be being reported to Honeycomb now. Let's see if I can find that. So hopefully one of these ones. Yep, so you can see how these bars are all red now. And at the top level, it says error true. But down here at the bottom level is where we should see the details of our exception. Or not. Where are they? I've got a feeling I've done something wrong here. It's not capturing this. Because it's not only supposed to know that there's an error, it's supposed to actually capture that text that I put there as well. Oh, I'm not going to deliberate on this too much, but the idea is that we basically wrap this in a thing. Where is that tracing.js gone? So we're calling out in a function and we're catching an exception. And if there's a span open, it's recording that exception. So this is the Open Telemetry API in action here, and we're recording an actual error. Just don't know why that's not coming up here. It's a bit annoying. Must have done something wrong. But there's other things you can do. So making it a span using this function start active span. So this is a helper function that calls another function. And ultimately what it's doing is just, starting a span, and then at the end, in this finally clause here, it's ending the span. So we could say, let's try that. Let's try putting that in make span. My database query. And we'll put all of that inside there. And hopefully that'll give us another span. So the error should be gone now. Just refresh that a few times. Make sure I've got some data in here. So you can see here that I've added a new span. So it's basically put timing, 15 milliseconds around this database query. I mean, it had that anyway. Although the interesting thing here is you can see that the actual MongoDB find was pretty quick, 10 milliseconds. And whatever I put around that was added an extra 5 milliseconds. So that's, it helps you unearth interesting things like this that you kind of you wouldn't necessarily expect. Okay, was there anything else to show you there? Have a look. So I've shown you how to make a custom span, and you can grab the code for this yourself, boot it up using Docker Compose up build, and add your own Honeycomb API key, and you can kind of try playing around with some of this for yourself. I tried to show you reporting an error. That didn't really work. I'm not sure why. I'd have to debug that and to find out why. I don't really have time. So I think that's about it. I'm just going to show you some resources that I use to learn. And I think most of this came from Andrei as well, Andrei's talk last month. So watch that talk and you'll probably get all the same stuff. But yeah, so this is the Honeycomb Quick Start Guide. So going through this, and it tells you for different languages how to get set up. I've also set this up for Go, which is a little bit more painful than getting it set up with JavaScript. That wasn't much fun. But the fact that it worked with this auto instrumentations for Node, it just worked so quickly and so nicely. I got so much for free out of the box. That was great. And even though you here's the example, tracing.js to add. So even though you're kind of locking this file to kind of Honeycomb and using the Honeycomb SDK to get started quickly, the rest of your application will just speak to OpenTelemetry, the OpenTelemetry protocol. So the only thing you have to change if you want to get away from Honeycomb is this file. I watched a few videos here from the Honeycomb resource library. There's a bunch of training videos here. They're all about 5 to 10 minutes long, so pretty small. I think I jumped in I was just looking for something in particular, and yeah, I think I jumped in at about topic 7, and I did about 5 of these videos, and they were really useful just to help understand how to use the Honeycomb software. Of course, Andrei mentioned this, and Andrei put me onto this in the first place. The OpenTelemetry Bootcamp. Really good, but this is I've only got a few videos into this myself. It's pretty good, but OpenTelemetry by itself, it seems way too complicated. But once you've got it set up, it's not too bad. But the Honeycomb SDK gives you a massive head start on that. And of course, the OpenTelemetry webpage and the documentation there. And if you go under instrumentation. This was a real help understanding how to kind of use some of the functions and stuff in JavaScript. There's a lot of examples here. I think this instrumentation section was a good one. So I was showing you how to make spans and how to add attributes and stuff like that. And also I spent a fair bit of time in the Go section here when I was for the Go library that I was, or the Go service that I was adding instrumentation to. So I think that's all. That's me wrapped up.
Fantastic. Thanks very much. that was a good intro, just trying to see exactly where we can plug everything together. And because yes, it kind of a little bit imposing, I think, if you want to start, especially, you know, given the deep dive we've looked at there about what OpenTelemetry can provide us and the like. So I think, yeah, you've definitely highlighted a couple of tools.
I think if you start with that OpenTelemetry bootcamp, I think you're gonna think it's really complicated. But if you start with a Honeycomb quick start, I mean, that put a fair bit of effort into just getting it, getting up and running really quickly.
Yeah, for sure. That's very helpful.
I'm not trying to be an advocate for Honeycomb. I haven't tried anything else anyway. So, you know, take my opinion with a grain of salt.
Maybe they should give you a kickback. Sounds good. Well, we've got a couple of questions, I think, that just sort of cropped up through the process of explaining and diving in. So some or may have been actually answered already, but we'll find out. We'll go through them anyway. First question's probably easy. This one is, what did you use to create the diagram in the repo?
Excalidraw, I think.
Excalidraw?
That's what I tend to use these days. I mean, I also use Kaku and LucidDraw, like a whole bunch of things, but Excalidraw is great for just quickly kind of creating a drawing that looks hand-drawn. Yep,
sounds good. Do you know if you can use the Honeycomb provided library for OpenTelemetry, even if you're not using Honeycomb? This one calls out Google Cloud Operations and, you know, other cloud vendor like AWS.
I mean, it's like hard-coded to read that particular API key from the environment variable, and even if you don't have that environment variable, you've got to pass that API key through in your Honeycomb configuration. So you could look at the code. I mean, you could look at the code for the Honeycomb SDK to see what they do, and that might be a head start, you know, if you want to use some other telemetry provider. But I would imagine that, you know, any kind of you know, any analysis or visualization tool for this kind of thing is going to have their own quick start guide that's going to kind of help you get started. So it's probably not something that's just specific to Honeycomb.
Yep, absolutely.
But yeah, you can't use the Honeycomb SDK with anything else. But like it could be a good guide if you want to know what the kind of nuts and bolts of, you know, the OpenTelemetry configuration look like. But I would say if you're gonna do that, do the OpenTelemetry bootcamp, because that's where you learn everything all in all its glory, all the nuts and bolts.
Sounds good. How do you choose where you place your span helper code?
It's hard to know. Like, I haven't really created any spans yet. So I've been augmenting my company's code, and I've had to. The hardest thing I had to do was like cross the bridge between JavaScript and Go. So that's automatic, like when you use the Node.js instrumentation and you're making a hop between two Node.js services. So we got that for free in that example I just showed, but you don't get that for free when you're going from JavaScript to a Go service. So you have to kind of like wire up into your request headers, or if you're using like a message bus, you have to add fields to your message payload that basically copy over like this identifier that's the ID, the GUID or the UID of the trace, and the UID of the parent span. And then when you end up in that other service, so in this case, that was a Go service, you have to create a new span. Like you have to manually create a span. This was basically, I mean, there is some automatic instrumentation for Go as well. It's just that we're using the Mosquito message broker, which didn't seem to have that. So I had to kind of, you know, replicate or make the connection across the services through the message bus kind of manually. And that's the only place that I've actually manually created a span, you know, apart from when I was just fiddling around and playing with it and learning how to do it. So I had to do it there for that. But in other cases, yeah, I haven't really felt the need for it yet. But I have been on a process of going through all our code and like adding events to understand what's happening, and, you know, trying to make sure all the exceptions are logged so that when an error does happen, we get, you know, as much details as we can about that. But I mean, I would use, you just use it to add understanding, add context around things. So if you've got a particular kind of sort of almost like a sub-process, like within the request that you want to understand, then just wrap it in a span. You'll get how long that took, you know, where it is in relation to other things that are going on, you know, after it, before it, above it, underneath it, that kind of thing. So it can be really helpful if you just want to understand, like, you know, where a bit of code is going to happening in the context of the bigger request.
Excellent. Absolutely. Makes a lot of sense. I think it's down to the pattern you're going to apply to your own code.
Yeah, I mean, the automated instrumentation is great, but you do have to do, to make it really useful, you do have to do like a lot of work. And like typically, if you're doing this in like a legacy application, you're not just going to go across like every line of code and kind of, you know, augment it or whatever, instrument it or whatever. You have to really target where the problems are. So in our case, we have particular problems that we want to solve. And we're using, you know, this higher level kind of observability to kind of help pinpoint the general area where those problems occur in the code. And then we're just drilling down on those kind of code modules and those lines of code as we kind of hone in on the problem. And we're basically, we're going in there and we're putting the extra augmentation in terms of attributes and errors and stuff like that. So you can't just take a legacy application overnight and make observability useful. But I mean, like I said, I was really surprised at just how much you get for free, and then that helped us kind of hone in on where the errors were. So we were able to kind of dive deeper on the code and understand what was going on in those particular areas.
Awesome. The next one on the list was, are there data sanitization concerns here? Are there methods to squash how much customer confidential data there might be in messages or data passed? I guess it's like squashing the logs.
That's a real concern, and I think you just have to be happy yourself that the automated instrumentation like isn't doing any of that. I mean, it's not randomly taking bodies of requests and, you know, pushing them to Honeycomb, or it's not taking random headers and pushing them to Honeycomb. Like all that kind of sensitive stuff, you have to make a decision yourself to add that, and that's where you have to be really careful, I think, because I don't think the automated instrumentation is going to like push any of your sensitive data to Honeycomb. Like that would be a real problem if it did. And you still have to look out for that just in case, but like I don't think it's going to do that. But you just have to be careful kind of when you're adding an attribute like a user ID, like you don't want to add a user password or something like that, right? Like that's an obvious no-no. But you know, any kind of customer sensitive data, you just don't want going into Honeycomb. So you just have to be careful. It's something you do while you're instrumenting your code, and just watch out for doing that kind of thing.
Absolutely.
Because I mean, like Open Telemetry and Honeycomb, they don't have any logic at all to kind of restrict that or to kind of redact, you know, values. Like it has no idea what a sensitive value is. So you just have to look after that yourself. Yeah,
for sure. Sounds good. I mean, you've got to sanitize logs anyway. Those kinds of things are very common.
Yep.
So there's a bit of confusion around the error wrapper, I think. This one says your error wrapper, does that only report if it happens to have the error thrown, or does it catch everything inside that call from the call stack? I think they were looking at that error wrapper you had.
Yeah. Any runtime exception that gets thrown, whether you've thrown it, like I tried to do that as a demonstration, but you know, any kind of exception from a library underneath that's thrown, and it's set up to be like async aware as well. So it's catching you know, errors for promises that are rejected as well. And that's just the way that I've set it up. So you can kind of, you know, if you make your own helper function like that, you kind of set it up any way you want. But yeah, like it should be capturing every exception that's happening, and then rethrowing it to whatever the next higher level is to deal with that, which could be like in the case there, it was Express. Express had like you know, kind of like a wrapper around my route handler that was catching errors and doing a 500 request. So that, I mean, that could be enough. Like that can be enough for you to know that an error is happening in a request, and for that information to get reported to Honeycomb. But to actually add an exception, you like have to catch it and add it to the telemetry system, add it to Open Telemetry that way.
There's another one here. Is there something in the toolkit for exporting Open Telemetry's metrics nicely as well? Got traces, but then there's metrics.
I think so, but I have not looked into that at all. So yeah, I can't answer that, sorry.
No problem. Well, someone from our audience can jump in. There's another one here from Sean. Hi, Sean. We've got, how does Honeycomb compare to open source self-hosted alternatives like Signos?
I haven't heard of that one. But if you do the Open Telemetry Bootcamp, they show you how to use open source tools instead of Honeycomb. So I mean, that's a good place to go to learn about like what the free alternatives are. So yeah, all I can do is suggest that you have a look at that.
Nice. There's another one here. How do front ends participate in the flow of a span? So I guess they're wondering if the front end interactions can be included.
I haven't set it up that way, but I believe it's possible to integrate like some of these SDKs into the front end, and so you can actually start your tracing from the front end, and that would be very interesting to see. But I haven't tried that yet.
Cool. All right, so it is possible. Go do some research, folks, and do another BrisJS talk.
We could start a chain of observability talks.
Yeah, that's right. Have one every week.
Who wants to do the next one?
Yeah, we'll throw at least one in. We'll have a couple of talks, and then we'll have an observability follow-up, like a lightning talk for each thing. Cool. There is one last thing in here, and I think it's funny. Is there a too much in your span capture? Like, I've captured too much.
Yeah, you know what it's like with logging. Like, when you're looking at production logging for like some system, there's always too much noise, and there's always too much noise, getting in the way of the thing that you want to look at. And I think with observability, like what we're trying to do is to really minimize that noise and just have more signal than noise, basically. But then again, like it's possible to overdo it. I think it's possible to kind of pump out too many events, too much data, too many attributes. But they encourage that. Like Honeycomb encourage that. You don't. I think you do pay per event. I can't remember. I haven't actually started paying for it yet. We're still on the free tier. So I think you pay per event, but the amount of data that you can add to an event, the amount of attributes, I think is unlimited. And they encourage you to send as much data as you can. And so you've got this kind of like, they call it like, I think high cardinality, like this kind of multi-dimensional like logging, basically. So you've got all this context around each event and each error. And a lot of information you can search on. And it's also they've got this thing called Bubble Up, which I haven't really got into yet, but it shows you like this whole page of like correlations between attributes. So you can help identify like, when there's a problem happening, or maybe like, slow performance or something like that, you can easily see the common bits of data, like, whether it's a particular user, whether it's a particular region, whether it's a particular like node in your cluster or something like that. Like there's all this information that can be used to correlate problems to find out, what sort of spectrum the problem is on.
Awesome. Yeah, no, that'd be very helpful. I think, as you're going through it, you need to try and identify all those bits and pieces. It's, you need to be able to try and make sure that you've captured enough to try and diagnose it in the moment then as well. Otherwise you're, seeing then again, we need to add this to our scope so that we can understand what's actually happened to that particular event. So yeah, trying to catch some of those things and being able to provide that observability that we need is pretty important. So that's fantastic. Thank you so much for diving into that.
That's cool.
Really appreciate that. I think everyone else does too.
I'll make all the resources available and a link to the code later as well, if anyone who wants to try it out for themselves later.
Awesome. Sounds great. And yeah, everyone, if you get into it and you discover some new bits and pieces, that's your future BrisJS talk. We'll see you here soon.
I'm looking forward to that next talk. There you go.
Excellent. Thank you very much. Awesome. We'll now be able to welcome Murray to the virtual stage. He'll be taking us through how we can speed up those pages when we've got a ton of data-heavy visualization. Welcome to BrisJS.
Thank you. Okay, how's the sound?
Good to have you here. Wonderful. We can hear you loud and clear.
Cool. All right, well, let me share my screen. And we
Got
can
it.
see everything. Okay. Are we good?
Sure are. Take it away, my friend.
All right, good. Well, this is an update of the talk that I gave in Singapore 3 years ago. I was involved in Singapore JS, and I thought maybe somebody here would find it interesting and hopefully useful. So let's see how we go. I don't really hate Tableau, but I hate the way they do stuff, so we'll talk about that. Okay, so my wife uses her phone for just about everything all day. And one of the most common things that she says during the day is, this site is sucky. And I go and have a look and I find that, yes, indeed, it is sucky. It's either slow or it freezes or it's unresponsive or you got to scroll everywhere or the font is too small or all of the above. And yes, it's definitely sucky. And we've decided that actually most sites are sucky and it's really not good. So our holy grail that we're talking about tonight is we're trying to get less than 1 second load time on the phone, minimal blocking by JavaScript and CSS, try to get as low bandwidth as we possibly can, no layout shift as things load, and so on. Now, I used to subscribe to Tableau Public, and they would send me a UView whiz-bang data visualization each week, and I would nearly always be getting the email on my phone, and I would try to open it, and it was just impossible. It was just awful. So, of course, I'm on a desktop here, so let's just see what this particular example looks like on a desktop. So 1,000, 2,000, 3,000, 4,000, 5, notice the whiteout, 7,000, 8,000, 9,000, 10,000, 11,000, 12,000. Oh, finally, we've got some action. So super, super slow and painful. And then I start to try and react with it. Well, slowly stuff comes up when I mouse over various sections, and fine, and then I click something and see what happens, and we get another whiteout and another spinner, and nothing seems to have happened. I click on it and whiteout and nothing happens, and it just drove me nuts. Now up the top here, we can actually choose particular fuels to sort by. Well, let's try and do that. I choose coal, whites out again, we have spinners again, waiting and waiting, and then finally waiting some more, and finally we get the country with the largest percentage of coal at the top, and then the next one, and then the next one. So it actually is just so painfully slow, it's just awful. Now, another thing is that they've sort of smoothed things out so that we can't see what's happening year by year. We also don't have anything along the x-axis, so we don't know what year anything is. And we don't actually, I mean, what's going on here? Isn't the energy consumption going up? And this was going down. And I just thought it was an awful data visualization. I saw something in here that I wanted to do some more searching on, and then I found that I couldn't select anything here. I couldn't copy, I couldn't do anything. And I think, yeah, I can do this link, but I can't do anything with this text. So all around, this was a pretty bad experience. So we go back to my slides and talk some more. As you saw, it was slow, it was bloated, it was clunky. It uses an iframe. I mean, I don't know why. Who uses iframe? It uses one huge background image, which I thought was very peculiar. And it's 1,500 pixels wide fixed, and it's not at all mobile friendly. So no wonder it's so awful on my phone. So Tableau, to say some nice things about it, it's popular for data visualization. It's versatile. It has many different chart types, like all of these, which are fine when they run, but you have to wait for nearly all of them. It allows filtering and sliders and can handle huge data sets. And I think fine, but if the user has to wait so long, and we know that users, if they wait more than a second, they usually go and look at some other site, it's kind of, what's the point? If people aren't going to stay and play with the thing, what's the point in doing all the work and actually developing it? So I did some analysis on it, and in Lighthouse, the page speed score was 11, which is pathetic for mobile. For desktop was 43. The bandwidth used is 8.95 meg. There's 1 megabyte of unused JavaScript comes down the pipe. It's clunky, it has whiteouts, as you saw, it ignores or delays user interactions, and so on. Now, the web page test result, when I analysed it in there, got a bunch of reds. What really freaked me out, there's 116 requests, 22.26 seconds loading time. There's sort of similar, some different tests give slightly different numbers here, but huge number of requests, long time to load, and it's actually calling from 20 different domains. The blocking time is 5.5 seconds. Overall, a really bad experience. The waterfall, the beginning of the waterfall looks like this. The first 16 requests are like this, and it goes on and on and on and on. Here is here's a screenshot from further down the waterfall. There's a whole lot left out. And the 21st, 22nd seconds, somewhere around there. And then there's a bunch more lines before the end. So I look at this and I think it's got a whole bunch of JavaScript that it's calling. It's got a bunch of web fonts that it's calling. And yet, as you saw, I couldn't actually select any of those web fonts. So why bother having web fonts? You might as well just have it all on an image. You're loading a whole lot of fonts that you don't actually do anything with. Well, that's the way it seemed to me. And then a whole lot of PNG images. It just goes on and on and on. It's awful. So I thought to myself, look, I'm sure I can develop something that's quicker and more satisfying than this. So I used the same data that they used. It comes from Our World in Data. I produced similar outputs, and this is what mine looks like. So just click here, and we're in, and it was under a second or so. And all these interactions are quick. And if I want to sort on coal, like I tried to do before in the Tableau thing, sort on coal, it's there immediately. Sort on hydro, it's there immediately. It's super fast, and actually you feel like interacting with it, having a look at it more closely, and so on. Now, I did this one as the individual fuel consumption amounts like this because I felt the Tableau chart really missed the details. There's lots of really interesting things going on here that you really couldn't tell. China, I thought, was actually starting to lay off its coal use, but as you see, it's still increasing. United States peak coal was achieved quite some time ago. And if I go back to here, Australia, you notice peak coal was back in 2008, and it's been downhill ever since. So you can look at things quickly, and it's satisfying, all the rest of it. Then I did total energy consumption by country. This looks more like the Tableau output, where we see actual additions as the fuel amounts go up. As time goes on, it actually goes up on my graph, which I think is the way that it should look. And once again, we have quick interactions, and it's all nice and fast. I can sort by the amount of hydro as the highest percentage, or nuclear as the highest percentage, or coal as the highest percentage, and it's all nice and quick and very easy to use. Another thing I wanted to point out was like this. I'll just show it to you on on the phone. If I can see that, let me just drag this stuff out of the way. And choose a phone. And as you can see, it all works nicely on the phone as well. No need to scroll to the right or anything. There's one error appearing down here because I'm using DuckDuckGo as an ad blocker, and it also blocks the Google Analytics. So there you go. So I'll go back to my slides. And how did I do it? So I'm using SVG for my charts. I'm not using any images at all. And I'm using inline SVG so I can do interactions easily. I create the SVGs on the server beforehand and cache them. So I just do that before I do the rest of the page. I have all the SVGs ready to go. I load 3 charts as the page loads, and all the rest are retrieved on Ajax, via Ajax as I scroll. I'm inlining everything, the CSS, the JavaScript, and the SVG. Every time you do a server call, it slows down your page load. And if your CSS and JS and SVGs aren't very big, why not inline them, and then it saves a bunch of server calls and everything just all arrives at once. I have what I call data blobs, which are needed for the graphic interactions. I create those on the server using PHP in my Ajax call. 3 blobs appear on page load, and the rest are retrieved by Ajax. And the data blobs are like this, just the various data that I need for the amount of each fuel that I've got going on, and some of the broad properties that I'm going to need for the various interactions. I'm using Cloudflare, and I'm just using the free version. I think it's wonderful they give us that for free. It's nice and fast and very useful. And I have the setting cache everything. I'm using one domain only. I mean, my own code is only calling one domain, but I can also run the Google Analytics. So how does it perform? Well, the speed of my improved version in LightSpeed, it's a 99 according to Google. The desktop is 100. GT metrics is showing that it's fully loaded at 136 milliseconds. So it's nicely underneath 1 second, and that's the whole page. As everything that's needed is all there in under 1 second. You'll also notice that nothing is jumping around in these thumbnails. As the page loads, everything is in fixed position. It's another thing that slows down the browser as you load a page. If it's got to refactor everything and decide where to put everything, it slows stuff down. So far better to have everything in a fixed place if you can, and allowing for different screen sizes, obviously. And things load nice and quickly. Locking time is 0 because I'm not actually doing anything CSS-wise or JavaScript-wise to mess up the page load. Web page test mobile result, I'm happy with everything. And the waterfall, this is it. Not 120 odd different server calls. It's just 2, one for my code, one for the favorite icon, and then my code then calls the Google Analytics, and Google goes off and slowly does what it needs to do to analyze my page and the user interactions. Now, the thing I point out about this is actually emulating a phone, 4G, and from London. And as you can see on a phone, it's even under 1 second page load time. So the bandwidth is 110 kilobytes compared to 8.95 megabytes in the in the Tableau version, so it's 98.8% better. Once we're fully scrolled down to the bottom, I load 273 kilobytes, which is 96.9% better than the Tableau. My JS library bandwidth is 0 because I'm not using any JavaScript libraries in there at all, so it's infinitely better. I'm not using any images in there. There's no IMG tags in there at all. It's all SVG tags, and they're all inline. So I'm saving 4.72 meg compared to the Tableau. So once again, infinitely better. And there's no cumulative layout shift compared to the Tableau, which is a 0.507, which is a real no-no. Anything under 0.1 is okay. 0 is even better. So my summary for fast pages, keep it lean, optimize everything, avoid unnecessary JavaScript bloat. This is my biggest bugbear. I just find so much JavaScript doing so much stuff on load, and a lot of it is unnecessary. A lot of it could be either held off until the page is completely loaded and then stuff done in the background. And then a lot of times it's just, I look at pages and I think, why are you doing that? Why not just load a nice, simple HTML page rather than a mountain of bloat, which is super, super slow. Reduce the number of domain calls. Now, if you've got advertising on your site, which I used to have on my main site, advertising is the worst thing for bloat. Just really, really pathetic. So what I used to do is I used to lazy load all my ads. So my page would actually load really quickly, and then the ads would come along later on. And I inline as much as I can. In the example that I showed you, I'm inlining everything. And also web fonts. Now, I'm not a great fan of web fonts because actually the Google web fonts are really quite slow to load, and they slow down pages quite a lot. And you also have problems with cumulative layout shift when you're using web fonts because your browser default font tries to load to start with, and then the page jumps around once you're actually loading your web fonts, unless you do swapping of fonts and so on, which I played around with, but still didn't find that very satisfactory. And it also was very slow. And as much as I can, I just do things just in time. If the user doesn't need to know what the graph for Zanzibar is until they actually scroll down to Zanzibar, well, don't load it. Only load it when they need it. And that applies to images and ads and whatever. So I'm a big fan of lazy loading as much as you possibly can. And I cache everything. Now, this is actually a bit of a hassle when developing, because whenever you make a change and then you upload the file and then you refresh and you think, nothing's changed. What's going on? And then, of course, you're getting the Cloudflare cache of the page. And I've written a thing that actually makes my purging of the cache a lot easier. That's the only minus in my workflow that I actually find. So, conclusions. Achieving page speed with a data-heavy page is possible, and no site should be sucky. Thank you very much.
I think that's one of the best closing arguments ever. No site should be sucky, and I tend to agree with that. Thank you very much for that. I think that was really good. We obviously got a few questions to dig into, some of the information around your approach, and I think other folks here, being the home of JS, have also wanting to compare things to some of the JS approaches as well. And I think the main, just looking at the questions here, the main point is the difference between, I think, the static data set and a continually updating data set in approach. So I'll just start with the questions. There's one here which is, are asking about the SVG. So are there any helpful libraries that you use that can generate those chart SVGs effectively for the static content?
Okay, so the story there is my main website was a mathematics website, and I had a lot of interactive doodads on it, which were graphs and so on. So I made a lot of use of JSXgraph, which is a library at the time. But I stopped using it because it's actually really slow, slow to load, slow to do stuff. And in fact, that's been my experience with a lot of libraries that I've used. I would use it and try to get things fast. I couldn't get things fast, and I'd just throw it away and generally write my own. And basically what's going on there is I'm actually doing a PHP port of a JavaScript library, a simple JavaScript library that just does simple charts. And so my PHP is just faster than doing it, and I can save it to the database easily and so on, more easily than I could with JavaScript at the time. So I just stick with it. So I'll just see if actually I'll dig it out later and I'll put it in the comments or send it to you, Kevin.
Yeah, sure.
The PHP version, I'm just trying to remember whether I wrote that or whether I got it from somewhere. Maybe I got the guts of it from somewhere, and then I did a lot of revisions or something. That was quite a few years ago, but I use that all the time now. But if you want fast, don't use JSXgraph.
Nice. We've got not what to use. The opposite. You got a counter example. So we've got another one here. If you wanted to update the charts in an ongoing basis, like a WebSocket to show the next 2-hour window of some data, would it be possible to utilize this approach of rendering it server side?
Yeah, I could do that. I could. You could have your charts like that, and then just by JavaScript, you could you could easily do that. I mean, sure, Node.js and stuff will do that for you, I'm sure, but it's slow.
Yeah.
I mean,
so
I'm very happy if you want to convince me otherwise, but in my playing around with Node.js, also I gave up with that because I found it was just so much stuff going on that it was actually slower than just using my own. I'm just using a really simple Ajax call. It just goes off, get me the latest information, and then come back. So yeah, I do believe you could do that with those charts, because what it would do is it would just take out the path that I'm using for each one, just remove the path and update it with the latest path. So yeah, it could be done.
Yeah, you can dynamically call the same data render set.
Yeah.
Which I guess goes into the next question a little bit. Have you compared JSON-based charting libraries with regards to rendering speed?
Answer no. As I said, anything that I've actually tried, I'm always trying, various libraries and stuff to try and find something fast. But I always just shake my head, giving up. I'm sure it's out there. I'm sure it's something fast out there, but I haven't found it. I'm just happier to work with simpler and faster stuff that I know is going to work for me.
Yeah, well, then there's the next question is not so much a question, more a suggestion. So the next one here is like, I used Lightning Chart in a minimal page in the past for JS rendered and live updating stock charts. Not as fast as a static load set, but it might be worth a check. So there you go. So we can link that as well. But that is the question set, my friend. That was fantastic. Thank you very much for taking us through your experiments there and how you can go back to that server-side data set and ensure that you've got a really fast loading page on mobile. And like I said, best closing argument: don't have a sucky web page. That's obviously one of the best things as well.
Your take home for the
Thank you. Oh well, I've taken home more than that, but I love the tagline. I think it should be part of an advertisement. Yeah, thank you very much for doing that, and taking the time out tonight to present to everyone as well. And hopefully we'll have some follow-up talks as well that maybe get into sharding libraries, and you can have a performance war with some of the other presenters.
Sure. Okay. Thanks, everyone.
Sounds great. Thank you very, very much. And that brings us to the close of tonight. We'll give a couple of quick closing remarks, and I'll just like to share with everyone some of the details to keep in touch. So yeah, as you can see here we go. There we go. Sharing's kicked in. Yeah, that's all the details here. As you know, I'm Kevin, and you can contact me on the Twitters as well as by email, and BrisJS is email handle and Twitter handle of course as well. You can continue to follow up with the Slido remarks. I have just enabled the open feedback poll, so you can leave some suggestions or any feedback at all about our streaming events. Yeah, we'd love to get your opinions and follow-up talks. And if there's anything that's been super cool in your world at the moment, and you want to be able to share, that would be fantastic to bring to the BrisJS audience. So don't hesitate. We've got our GitHub issues link there as well. And following this, also on Twitter, I'll post the new submission link. It gives you a little pro forma thing that you can fill out on the GitHub issues as well. So yeah, that will be probably the easiest way to just jump in. Otherwise, do visit brisjs.org, find that present link, and you'll be able to be redirected through to our GitHub issues as well. So we'll tag that and then keep in touch. We've already got one presenter lined up for next month, so I'll be able to update the information on the meetup page very soon around that one. But thank you very much for joining us tonight, and hopefully found this enlightening and or at least entertaining, and hopefully we'll be able to see you very, very soon. And it's just some weeks away now. We've got BrisJS coming up for April, and we hope you can set yourself a reminder and keep in touch. Thanks very much, everyone.